Finally, let's discuss finding extrema on a closed interval. Remember, extrema means the max and min values, the absolute max and min values, and on a closed interval, they must exist. Remember, the extreme value theorem tells us these must exist. On a closed interval, we have to have them if we have a continuous function. So let's think back to that first picture where we can have absolute maxes and mins. In this first picture, they happened at the end points. Here was our absolute max, here was our absolute min. In the second picture, our absolute max and mins happened at hills and valleys. So at the critical numbers, where there was a turning point in our graph or something critical happened, like a drastic change in slope. So let's remember that these absolute maxes and mins can occur at critical numbers and endpoints. So that's the most important thing to start with, is thinking about remembering when can these maxes and mins happen. So then it helps guide us in what we need to do. So looking at problem number 1, determine the absolute extrema and the x value where it occurs. Well, notice that you're given a closed interval. So we see we have a continuous function, we have a closed interval. Extreme value theorem tells us that we must get an answer. We must get a max and a min, because this is a continuous function and this is a closed interval. So we think to ourselves, well, maxes and mins can occur at critical numbers. Do we have critical numbers? Not yet. So our first step is find the critical numbers. Remember, that means where f prime equals 0 or does not exist. So let's find f prime of x. 12x cubed minus 12x squared. Well, this is a polynomial, so there's no place where it doesn't exist, but there is a place where it equals 0. So let's solve for those zeros. I can factor first, and then of the factors, I can see x equals 0 and x equals 1. So those are my two critical numbers. So the first thing to do was find the critical numbers, and we did that. Here are our critical numbers. Now we remember, okay, they can occur at critical numbers, but maxes and mins can also occur at endpoints. But we don't have to find endpoints. The endpoints are given to us. Done. So now we have to remember, well, let's see. Max and min means the highest and lowest function values. So that's step 2. Evaluate the function at the critical numbers and at the endpoints. So step 2, evaluate. So my critical numbers are 0 and 1. So I need to do f of 0, f of 1, and my endpoints are -1 and 2. So I need to do f of -1 and f of 2. Remember that we're looking for the highest and lowest function values. Max and mins mean the highest and the lowest. This is the y value, so I'm evaluating what y is. I'm evaluating the y coordinate. So we're plugging it into what y equals. So that's 3 times 0 to the 4th minus 4 times 0 cubed. That makes 0. Let's evaluate the rest. 3 times 1 to the 4th minus 4 times 1 cubed, -1. And then the endpoints. 3 times -1 to the 4th minus 4 times -1 cubed, that makes 7, and 3 times 2 to the 4th minus 4 times 2 cubed, that makes 16. So now that we've evaluated them, we just have to identify which ones are the lowest and the highest of our values from step 2. So I see of these 4, this one's the lowest. So -1 is the min, and highest, 16, is the max. Now our question said, also find the x value where it occurs. So there's the x value and there's the x value. So we can say at x equals 1 or at x equals 2. Welcome back. Finding critical numbers first. Take the derivative. 2 minus 2/3 times 3 is 2. X, subtract 1 from the exponent, negative 1/3. Move that negative exponent down to the denominator. It looks like that. We can set this equal to 0. So where g prime equals 0, where 2 minus 2 over x to the 1/3 equals 0 is going to be where 2 equals 2 over x to the 1/3. That's going to be where x to the 1/3 equals 1. Multiply by that, divide by 2, cube it, and that's where x equals 1. So there's one critical number. It exists in the function, so it is a critical number. Where does g prime not exist? I see a denominator. The denominator will be 0 when x equals 0. So again, is defined at 0. I've got two critical numbers. One is at x equals 1, and one is x equals 0. Step 2, plug these guys in. So plug in my endpoints. G of negative 1, G of 3, critical number of 1, critical number of 0. G of 1, G of 0. What are those values? Plugging them in, I get for negative 1, 2 times negative 1 minus 3, negative 1 to the 2/3. That looks like negative 5. Plugging in 3, I need a calculator for that one. Negative 0.240 using my calculator. G of 1, I plug in 1 and I got negative 1, and G of 0, I got 0. So now we're determining the highest and the lowest. So of all of these values, it looks like the highest is 0. So 0 is the max, and looking at the x value, it's occurring at x equals 0. Finding the lowest, negative 5. So negative 5 is the min, located at x equals negative 1. Another AP test problem. The absolute maximum value of this function on that interval. So they're only asking for the maximum there. And notice they didn't say where it occurs. So if it's just the absolute maximum value, that's just the y value, and that's all they want. So let's go ahead and find the critical numbers first. F prime, 3x squared minus 6x. No place where this is going to be non-existent polynomial, so set it equal to 0. Looks like we can factor 3x, and we get two critical numbers of 0 and 2. Now we can plug those and our endpoints into our function. So let's determine f of 0, f of 2, f of negative 2, f of 4. And keep in mind, we're only looking for the max. That's all we need. Plugging 0 into the original function, 0 cubed minus 3 times 0 squared plus 12 looks like 12. Plugging in 2, we get 8. Plugging in negative 2, we get negative 8. Plugging in 4, we get 28. The maximum value, just the y value, is 28.